hope you all are having a great week. Here it's all nice and rainy and overcast in LA, which is a great time to talk about Amazon SageMaker and MLOps, and a big project we recently did with image data. So we're trying to help people overcome some of the issues that we saw. And then we've got a great cast of characters today for this webinar from Mission Cloud, and I'll talk about who we are in a little bit. We have Dr. Nayu, who has started to focus on MLOps and learning everything she can. And then we have two AWS presenters, Dr. Joe Zhang, who is a senior partner solution architect, and Dr. Mario Bergain, who is in that partner org as well, who has been doing tons of MLOps and going to really dive deep into the MLOps SageMaker pipelines and everything else that AWS is offering in that arena. So I kind of gave you the brief agenda already, but first I'll give the couple of minutes speech on Mission and MLOps and why people should care about it. And then we're going to go into SageMaker pipelines and MLOps orchestration, which plays that vital role of keeping your models up to date. Then Na will talk about best practices and tips that we've come across with SageMaker pipelines. And then finally, Joe will be speaking about federated learning, which is really a fascinating topic on how to think about your training, and something that you guys should all be looking at as you're thinking about models and what it takes to do training of giant data sets. So who is Mission? Mission is a premier AWS partner. All we do is AWS, right? We don't work on any other clouds. We're completely focused on the AWS ecosystem. We were funded, a little over 5 years ago in 2017, and have worked with tons of customers, and have, over 300 people on our team. Some of our true core competencies are in, machine learning, data migration, life sciences, healthcare, all kinds of areas that, a lot of customers are looking at, high tech, cutting edge. So with that, our true focus areas are really doing anything that a customer needs along that full stack, right? Are you looking to optimize your cloud spend and security? Are you looking to modernize? Are you looking at, hey, what does this need to be to do software and application development, or often it's termed cloud native development, and then everything in the data space, right? And this one really webinar really focuses on the machine learning aspects. So, let's get into some machine learning. Next slide. So now, as you can probably think, if you're a machine learning expert now, you're really seeing AI ML every day, right? I'm sure you talk to your Alexis or maybe Siri or anything else, asking it questions, right? That's really backed by NLP and large language models. And, there's all kinds of work that's been done on translation and everything else in that stack, right? As you probably look in your spam filter, right? Email spam filtering was one of the early use cases for ML. And so that whole service, continues to be improving. And, it's just a piece that you see every day. And so when you think about these services, a lot of work has gone into those. But if you look at the reports of where machine learning stands today, only 22% of companies, right, according to Forrester, and they surveyed a couple of thousand companies, only 22% of those companies actually have successfully deployed machine learning models, right? Which is pretty crazy when you think about it, right? Only 1 in 5 people have actually taken the work their data scientists do every day and put them into production. So what really happening there, right? A part of it is, the environment has not been set up for success. You have your data engineering practice is a separate practice versus your data scientists. They have conflicting goals. And so then the data scientist work never gets put in, or, you just aren't able to cross that chasm and bridge between the two. A lot of issues we've seen in our own work is that data is still siloed, right? Where you still have a lack of data engineering skills and all that to get to the data. And there's collaboration amongst teams that's really hard. And then some people just chose poor use cases. But anyway, this Forrester report just came out about a week ago. It's a pretty interesting read if you guys want to look at it after this. So what's going on in the world as far as use cases go? I kind of put this together, a few sentences on what are candidates, right? And you want to be sure to answer these kind of business questions, right? We want to predict some customer behavior, or we want to enhance a customer experience, or we want to improve business efficiency, right? Those are often really good questions to ask, for AI/ML and how it can work for you. One of the things that is a challenge, as I mentioned in the data side, you're starting to see people start to talk about new data infrastructure, right? The data lake was a construct and everyone had a vision of, hey, let me throw all of my raw data into one spot so that everyone has access to it and create curation zones and all those good things. Unfortunately, that didn't work, right? And so people are now looking at data mesh architectures or data fabric architectures where each individual part of your business is now looking at, hey, I'm going to put out a product, and from that product, people can take that and use it in their machine learning algorithms. So people are trying to solve that challenge of their data infrastructure. So what happens with all of our data scientists, and you can see this is really a pretty big looped slide, is that there's all kinds of interconnections that have to happen, right? A data scientist is working with the business analysts, and if you're doing IoT, hardware engineers and data engineers, and you've got this big cycle of how the data flows and moves, and this whole process has to be captured, and you want to automate it, right? And so next slide, Nah. So that's really where the MLOps piece comes into play, which we want to talk about today, right? Is now I've got all these different groups of people, and I have all these processes that need to be working together. And how do I do that? That's how we create MLOps pipelines, where it puts together, the design of your algorithms, plus the model development and deployment and your operations, right? Of how do I monitor it? How do I keep it up to date? Every model has a lifetime, and it's important to understand that lifetime. And that MLOps will then use information you put in on model lifetimes and all that. And as data changes, right, with COVID and now the economy changing, data is changing all the time. So it becomes critical to have that key MLOps strategy. So I'm going to turn it over to Mario now, and he's going to talk through everything about MLOps and SageMaker pipelines.
Hello, my name is Mario Borgwijn. I'm the AWS Global Tech Lead for MLOps. I'm here to talk to you about the core of the AWS MLOps offering, which is SageMaker pipelines. This is our agenda for today. First, I'll review what is MLOps and its relationship to the machine learning lifecycle. Then I'll describe what is the SageMaker MLOps offering. Then we'll dive deep into three SageMaker MLOps components: SageMaker projects, SageMaker pipelines, and SageMaker model registry. Let's look at the ML lifecycle. Machine learning is a very iterative and collaborative process. There are teams of data scientists and ML engineers working with DevOps engineers to put models together to solve business problems. There's a lot of iteration and experimentation that goes in building the model itself through steps like feature engineering and model building and training. And once the models are built and trained, you have to manage them in production, making sure that they are scaling and running as a production service. Even then, there's a lot of iteration involved, as you have to retrain your models and keep them updated so that they're always accurate and representative of new data. The SageMaker MLOps offering supports this iterative process. Amazon SageMaker helps you automate and standardize MLOps across your organization. Amazon SageMaker Pipelines is a fully managed feature that helps you automate and orchestrate different steps of the ML workflow, including data loading, data transformation, bias detection, model building, training, and evaluation. With the Amazon SageMaker Model Registry, you can track model versions, their metadata, model performance metrics, model approval status, and group them by use case. Model Registry is a central repository from which it's easy to choose the right model for deployment based on your business needs. Amazon SageMaker Projects brings orchestration practices to ML, such as source code version control, automated testing, end-to-end deployment. Use projects to standardize ML deployment processes and accelerate model deployment from days to minutes. Amazon SageMaker logs every step of your workflow, creating an audit trail of model artifacts such as model training data, platform configurations, model parameters, and learning gradients. Use audit trails to recreate models, debug potential issues, and meet compliance requirements. Amazon SageMaker Model Monitor detects data drift and concept drift in models deployed in production and in real time. This allows you to automate the task of maintaining the quality of model predictions in production. Amazon SageMaker offers a comprehensive set of security features, including infrastructure security, data protection, authorization, authentication, monitoring, and auditability to help your organization with security requirements that may apply to ML workloads. Let's look at the components that automate the model creation and deployment process. There are three SageMaker components a team can use to automate a machine learning workflow. There are SageMaker projects, which provide standardized frameworks for ML projects, including source code control through model deployment. There are SageMaker pipelines that orchestrate the end-to-end ML operations, from data transformation to registering a good model. And there are SageMaker model registries that keep track of the models that the team wants to push to production. These components work together to provide a seamless automation of a team's ML lifecycle. Let's first look at SageMaker pipelines component. This is an example of a SageMaker pipeline. It consists of multiple steps that have been organized in sequence. The first step processes the raw data from an S3 bucket. Then there are steps for model training, model evaluation, and model registration. It also includes a condition step that compares the model's evaluation accuracy to a standard. Only if the model meets that standard does it get registered for deployment. Otherwise, the pipeline goes to a fail step. All the while the pipeline runs, it records the sources used, objects created, and metrics produced in a SageMaker experiment. This model lineage tracking supports troubleshooting and traceability and improves model usability. Teams can create multiple variations on this pattern, including using other step types. First, the training step can be replaced with a hyperparameter tuning step. And instead of only failing when the model does not meet the bar, there can be a Lambda step to send an alert about the failure. There is support for additional AWS integrations, such as with Amazon Glue or other AWS service, as well as additional SageMaker steps, such as EMR. Pipelines can also run multiple steps in parallel. Let's look at how to create a SageMaker pipeline. Creating SageMaker pipelines is done with code. The team creates the individual steps for the pipeline, then the steps are combined into a workflow. Finally, the pipeline can be used. We'll dive deep into the code to create a step. This shows the training step of the example pipeline. Each step has a name. It has may-define inputs and has outputs. By setting one step's inputs to use another step's outputs, you specify the order of the steps. You can also specify the order by explicitly declaring that a step must wait for another step to finish. Next, we assemble the steps into a pipeline. You join the steps together using a pipeline object with a name. Then you submit the pipeline to the pipeline services. that either creates a new pipeline or updates the existing one. From then on, you can use that pipeline directly from the pipeline services. Once your pipeline is ready, you can start it and wait for it to finish. SageMaker Pipelines includes multiple features to save time and reduce costs. You can introduce variables into your pipeline definition using parameters. These let you use pipelines for multiple purposes. You can use a pipeline with different data sets, such as using smaller data sets when testing the pipeline to save time. You can set how many compute instances and what type are available for computation to control costs. Parameters have a default value which you can override when starting a pipeline. All parameters used by your pipeline steps must be included in your pipeline definition. Another useful feature is step caching. When you run a pipeline after making a small change, you may not want to wait long to get results. When you turn on step caching, the SageMaker pipeline checks to see if the arguments of that step have changed. If not, it skips that step and uses the outputs from the last time it was run. That saves you valuable development time and the cost of experimentation. Step caching can be turned on and off for particular steps. It's available for the following 7 step types: processing, training, tuning, transform, clarify check, quality check, and EMR step. Let's turn to the SageMaker Model Registry. The Amazon SageMaker Model Registry is the single source of truth for machine learning models. Once a model is good enough to be deployed, you should add it to a model registry. Best practice is to include a model's metadata and performance metrics. Once a model is marked approved, it can be deployed from the registry to testing and then to production. Let's talk about model groups and model versioning. When a model is added to the model registry, best practice is to add it to a model group. A model group is a collection of registered models that solves a particular business problem. Best practice is for every model in a model group to be drop-in replacements for each other. They should accept the same types of inputs and produce the same types of outputs. If the deployed model version of a model group is failing, you can use the model registry to roll back to an older working version of the model. Let's look at how the SageMaker Model Registry is used. To add trained models to a model group, the first step is to create that model group. All that's needed is a group name and a description. Once you have a trained model, you can register it. You must supply at least the model artifacts produced by training and the inference code that applies the model to new data for predictions. You may supply the name of a model group for the model. The simplest way to register a model is to use a step in a SageMaker pipeline. You can also register a model using its register method or using the Boto3 SageMaker client. All of these return a model package ARN. To deploy a model from the registry, you use that ARN to get a model object, then call the model's deploy method. By default, a newly registered model is restricted from deployment from the registry pending approval. Finally, we dive into SageMaker projects. SageMaker projects provides a CI/CD architecture that uses SageMaker pipelines and model registry. Projects provides automation to kick off a model building pipeline when there's new code or new data or some other event. Projects can also deploy a newly approved registered model to testing or production. There are 3 steps to using projects. You can create new projects in SageMaker Studio or programmatically. From the Studio approach, first you select SageMaker resources from the toolbar. Then you navigate to the Projects tab and click to create a project. You then choose a project template with the features that you need. You can choose from one of the 7 standard SageMaker project templates to date, or you can choose some templates created by your organization. Then you enter the project details. You name your new project and can add custom tags to identify it. The resources provisioned through the built-in templates have project name and project ID tags assigned. When you click Create Project, everything needed to create a CI/CD pipeline for machine learning is automatically provisioned and configured for you. Let's look at what's in the model building, training, and deployment project. This architecture has two sides. On the left, there's model building. On the right, there's model deployment. The model building side includes a code commit repository, a SageMaker pipeline, a model registry, and a code pipeline. Committing new code to your repository triggers the code pipeline. That in turn triggers a SageMaker pipeline. Once the model is built, the pipeline then registers it as an unapproved model in the registry. Giving model staging approval triggers the code pipeline on the right to first deploy a model in staging using Amazon CloudFormation. Finally, once the stage model is approved, the code pipeline can deploy the model to production. Let's dive deep into how you can create your own customized SageMaker project templates. If the SageMaker provided templates do not meet your needs, you can create your own templates. To do this, you may need to have administrator access to SageMaker templates. You start from the SageMaker provided templates to understand how to organize your code and resources. Then you build your template on top of it and save it to S3. Next, you add your template to a portfolio. You log into the AWS Service Catalog, choose Portfolios, and choose Imported. You then create a portfolio or use an existing portfolio. You add your template to the portfolio as a product tab with the following key and value: SageMaker Studio Visibility True. Then your organization's SageMaker Studio's users can create a project with your template. Let's summarize what we learned. Today, I reviewed what is MLOps and its relationship to the machine learning lifecycle. I described what is in the SageMaker MLOps offering. Then we dove deep into three of its MLOps components: SageMaker Pipelines, SageMaker Model Registry, and SageMaker Projects. After today, you can use SageMaker Pipelines to add an MLOps automation to one of your projects. Thank you.
Awesome. Thank you, Mario. Very informative information on MLOps and how to use SageMaker pipelines and SageMaker projects. These are definitely great tools. Be sure to check them out.
Great. Thanks, Maria. Okay, let me share my screen here. Okay, yeah. Hello, everyone. My name is Na Yu. I'm a senior big data engineer with Mission. I'm going to share some best practice and tips of using SageMaker pipeline based on a recent client project we worked on. The starting point of our project was the client was doing a lot of computer vision model, PyTorch based, and they were training the model on EC2, and they were using Docker to deploy the model in their production line. And there were three main pain points in their workflow. Number one, they have a very huge cost due to constant running EC2 instances for their training job. And number two, it was quite difficult for them to manage how to handle the model version management between the research team and the production team. And number three, there was no feedback from their model in production back to their research team so that to help their research team to better improve the model. And with those three main pain points, they were looking for a solution to develop an end-to-end MLOps workflow and using SageMaker pipeline to resolve the challenges they were having. And for there were a lot of models being migrated, and for each model migration to SageMaker, we were having four main steps: from the initial model discovery and the architecture design of the overall solution for each of the model, to model refactor, where we did the lift and shift the model as it is to SageMaker, and then to the modeling pipeline, which is the focus of the presentation today, how to use the enable the researcher or data scientist to interact with the SageMaker pipeline notebook to build, train, and register the model. And the last stage is the deployment pipeline, where we use the registered model version from the modeling pipeline and deploy the model in the production. And this slide shows the overall pipeline architecture of our overall solution. There are 3 accounts, from left to right. In the dev account, where we have the modeling pipeline built in the Jupyter Notebook, where the researchers and the data scientists can build and train and register model. And then the registered model of the version will be saved in the SageMaker model registry, which is in the shared service account. So this is a multi-account deployment. And the SageMaker model registry acts as a handoff between our modeling pipeline and the deployment pipeline. And then the deployment pipeline takes that registered model version to go to tester account and the production account. And this slide shows our overall pipeline steps that we built for one typical model. As Maria showed earlier as well, that there are many steps that you can create and customize using SageMaker pipeline. And from left to right, we have, for example, defined pipeline parameters such as the training instance or learning rate as inputs. And the user can easily tune these parameters from a UI console on SageMaker Studio, on the Pipeline Studio, which is very user-friendly. And we start with a processing step where the image augmentation was done. And before the training step, doing the model training, you can bring your own training script. And after training step, we used a processing step to evaluate the model. Any customized evaluation metrics are calculated here. And then we used a condition step to compare the calculated metrics with an user-specified threshold. If it does not pass, then a fail step is created to send a notification message to the user, and then to help the user further tune the model itself. Otherwise, the model can be registered in the SageMaker model registry. And the last step is using Lambda step to create the endpoint in the dev account for researchers or data scientists to do any local, say, latency performance test. And as we can see, the S3 bucket was used for both the training step and the register model step to store any model artifact. So as our outcome, running through the SageMaker pipeline notebook, this is a DAG flow that we generated from the training step to evaluation step and to the end of the deployment, deploy the model step at the end. And as Maria mentioned earlier, one great advantage of SageMaker pipeline is that it provides very great data lineage for each of the steps. If you go to SageMaker pipeline console, by clicking each of the steps, you can see what's the input, output of each of the steps. And so in this way, when you do multiple trials or experiments, you can easily track down what version you used for your particular trials. And each of the data lineage, the lineage you are seeing between the steps are automatically created by SageMaker pipeline based on the data lineage between the steps. And this slide shows a brief overview. I'm not going to deep into this, but this shows the deployment architecture we built. So when the registered model is saved in the SageMaker model registry in the shared service account, along with, say, container image or other S3 model artifact, the code commit was used as a code repository, and the code pipeline is used to deploy the stack. And we were using CDK. And in this case, we're deploying the model endpoint to testing account and the production account. And in each of the stack, the stack can launch the endpoint, the SageMaker endpoint, the Lambda function, and the API gateway in the for the end deployment. And in between, there is a manual gate, or you can do automatically trigger as well. before I dive into the 3 best practice I'm going to show, I would like also to share some of the key resources we have used and found super helpful when developing our own pipeline. The first one is on the left. It's the SageMaker Developer Guide. Here you can find a great very conceptual and theoretical explanation for each of the service on SageMaker, and also it points to a lot of the related resources. And on the top right is a Python SDK. So when you begin to go to the hands-on development on the code line by line, you can go to the Python SDK to see, for example, here I'm showing an example for register model where it shows all of the input parameters, how to configure them. And the last one is on the bottom right, which is the SageMaker GitHub notebook example by AWS. And they provide great examples, end-to-end notebooks of how each service can be used. You don't always find exact use case as yours, but there are great resources to start with to see how a service is used end-to-end. The first best practice I want to share is how to deploy a PyTorch model with a customized inference script. So this slide on the right, it shows a typical example when a customer bring your own model, bring your own training script, how you would deploy your model, right? So you have a PyTorch estimator, have a training script, and then you call a fit method to train the model, and you have a deploy method to deploy the endpoint. And so this can solve your problem if you just bring your own training script. But if you have a customized inference script separately, this solution won't satisfy your goal. And the way to do that in SageMaker pipeline is, instead of using the PyTorch estimator, we use a PyTorch model object instead here. So in this PyTorch model object, you point to the model artifact outcome from the training step. And then in the entry point, this is where you can bring your own inference script, customize any kind of input processing or post-processing in the output function. And then, so this model PyTorch can be used either in the register model step or the create model step for the deployment, endpoint deployment at the end. And so to briefly summarize here, the main difference here is really to understand the difference between when to use an estimator, vice versa, or model object. Both of these two can be used when it comes to deploy model. But however, the estimator is more like a high-level interface where it abstracts the training packaging in one single Python class. While if you want to have more customization, say bring your own customized inference script, that's where you need to use a model object. The second best practice is about how to define customized metrics. So SageMaker itself provides great visualization when it comes to how you want to track your metrics when you do experiment. And so this example shows how you can, if you have customized metrics, how you can enable your training script to show those metrics through either the experiment or CloudWatch. So we also start with our PyTorch estimator, where you define your training script. And in the metrics definition, this is where you can define the metrics you want to track and display it on the experiment or CloudWatch. And so here, there are 4 metrics example here. The first one is the training epoch loss. So it starts with a name, and then a regex of the format of this metrics. And the trick is to make these metrics displayed properly. What you need to do is in the training script, in the train.py, you need to, first calculate these metrics correspondingly, and 2, use the logger method or a print method to log these metrics in a proper way. Once these are configured correctly, as a result, you can see 2 ways of these metrics. One is under the SageMaker experiment. If you go to trial and under metrics, this is where you see the numbers, the values for each of the metrics, and you can easily track them. And the second way is under the SageMaker Studio. If you go to individual training job, and you can see the direct CloudWatch link for each of the metrics. The last best practice I want to share is how to enable spot instance. So one of the big advantage of cloud is you can utilize cheap instances for your training, and a spot instance on AWS can save to about like up to 90% comparing with on-demand instances. So if your use cases can tolerate interruptions, right? Like especially for use case like deep learning, where it already have frequent checkpointing, this can really take advantage of spot instance. And in SageMaker pipeline, to take advantage of this feature to enable the spot instance, still we start with our PyTorch example here. In the estimator, there are 3 parameters here. One is use spot instance, set true or false, and the max run, which refers to the max duration time of how long the spot instance can run for the training job. And the max wait refers to the max run plus the time that the training job is waiting for the spot instance. And the trick is, so one, you need to definitely set the max run bigger than max wait. And then other things keep in mind is if you don't set any customized value here, like in this example, right? So max run, max wait for either true case or false case. If you don't set any customized value, SageMaker by default is 24 hours for your max run. And overall, the AWS account itself, it has 28 days for your overall training. So you can't set up more than that for 28 days. And your enterprise account might need to request for more longer time instead of the default one. And in addition to all of these configurations, the training script also need to be configured in order to save the needed checkpoint. So as an outcome, if you want to visualize or see how much saving has been achieved, so you go to the SageMaker console, the training job, and under this manage the spot in training savings, this is showing the roughly estimated savings that has been achieved. Here is showing 0 because I did not turn it on, but this is usually minus like 60 or 70, even 90% of savings. Yeah, and that's all of the best practice I want to share, and I hope this best practice can help you develop your own modeling pipeline easier. And next, I'm going to pass on to Joe to talk about federated learning.
Hi, this is Chung Zhang. I'm a Senior Partner Solutions Architect from AWS. Now we're going to talk about federated learning and whether it is the right choice for you. There are growing importance and attention to privacy as represented by this worldwide GDPR fines. There's 20 times fines in 2021 Q3 compared to the sum of Q1 and Q2. There are also many privacy enhancement methods. If we compare the transformer power of privacy enhancement methods, we can see that we have a multi-party computation, zero-knowledge proof, and others. Federated learning by far stands out among these options as the most effective one. In this session, we're going to talk about what is federated learning, why is federated learning growing in importance, and how to build federated learning operations on AWS. Federated learning is a distributed machine learning approach that trains machine learning models on distributed datasets. Let's walk through an example. Imagine that there are 5 banks in 5 different countries, each wanting to fight crime. They'd all like to find a better financial crime model. Each of them has their own dataset. Each of them has its own IT group and machine learning systems. And each of them has already detected fraud patterns to fight financial crimes using their data. However, more international banks discovered that their crime has different patterns, and some banks might uncover fraud patterns that other banks have not. If all these banks would put their knowledge together, they may discover one global fraud model and would fight financial crime much better than any of these individual ones. The problem is that none of these banks like to share their data. They each have sensitive customer information. They have a natural aversion to share customer data with their competitors. Federated learning provides a mechanism here to collaborate. It enables sharing data to train a central global model using the customer experience data from all this enterprise without sharing proprietary data. That is what federated learning is all about. The terminology is simple. On the left side, you see the federated learning clients. They can be on premises, they can be at the edge, or they can be on the cloud. On the right side, we have a federated learning server on the cloud, which is responsible for the aggregation of a global model. The goal is to improve the accuracy of the individual client's machine learning models while preserving privacy. We will see other benefits later as well. Individual federated learning clients share their local models to a federated learning server that takes those local inputs and aggregates them into a global model. The global model is in turn sent back to each of the federated learning clients. As a result, the global model usually performs better than their local models. And here we can see that federated learning exchanges machine learning models between the central server and the clients without moving training data to a central repository. So why is federated learning important? We have observed 4 benefit patterns of federated learning. The first pattern is cross-device, where thousands or even millions of devices, such as mobile devices, collaborate together to train a global model. The benefit is for privacy preservation. The use case areas for cross-device federated learning include edge machine learning, retail, and automotive areas. The second pattern is cross-silo, where tens of hundreds of organizations and companies work together to train a better model. These organizations and companies have their own data set and their own local models, but they can use federated learning to train a global model that is more accurate than their own local models. The use case areas for cross-silo include inter-institutional collaborations, financial service industry, government projects with highly sensitive data. And the third pattern is intra-region training. Due to data localization, operational challenges, or high cost of transferring large amount of data to a central repository, federated learning can be used to train models across distributed datasets within the same organization. Hence, the purpose of federated learning here is for cost saving. Its use case areas include applications requiring global reach. And machine learning with a larger data size and relatively smaller machine learning models benefits more, since exchanging smaller machine learning models in federated learning saves more data transferring cost. And the fourth pattern is hybrid cloud that provides operational flexibility for data. In this scenario, a local dataset can be augmented with other cloud available datasets. It's also used in high sensitive use cases for efficient bursting. When some companies use the cloud just to burst for excessive capacity and need spike, they don't need to move everything into the cloud. You can leave your on-prem in your own prime environment and still capture and harvest the learning from that. Federated learning can be applied to different vertical industries, such as financial services, life sciences, industrial AI, public sector, telecommunications, and transportations. So how to build federated learning operations? Here we show the steps for federated learning operations. On the right side, we have the federated learning server, which includes a model registry. On the left side, we have a single federated learning client, but actually we can have many federated learning clients here. Federated learning operations need to provide continuous integration and continuous delivery. Therefore, we need a code repository and for the server and the clients to agree on customized algorithms. A global model, such as the model.py, and the configuration information for the server and the clients to interact with each other. Step 0 here is to set up the Federated Learning server and the clients after downloading the Federated Learning package and trigger a Federated Learning task. Note that any change in the code repository, once agreed upon the clients, and may trigger a new Federated Learning task. Step 1, after a Federated Learning task is triggered, the Federated Learning server notifies clients that, hey, the global model is ready. Step 2, Federated Learning clients download the global model from the Federated Learning model registry. And step 3, Federated Learning clients start local training, and local training generates local models. Step 4, clients upload their local models and the local model information to the Federated Learning model registry, including the number of samples in the local data set, the client ID, the local training, and the testing accuracy, etc. Step 5, once there are enough local models collected at the Federated Learning model registry, the Federated Learning server aggregates the local models into a new global model and writes it back to the model registry. Step 1 to 5 is a single Federated Learning training round. There can be hundreds of Federated Learning training rounds until the number of Federated Learning training rounds reaches a threshold. Step 6, deploy and monitor the final global model at inference site. Here we compare Federated Learning operations and the machine learning operations. Machine learning operations includes centralized data preparation, training and tuning, and model deployment and monitoring, while Federated Learning operation includes parallel data preparation at clients, Federated Learning, and model deployment and monitoring. And actually, the model deployment and monitoring of Federated Learning operation may reuse what MLOps has. Now let's see a demo. Here you see 3 windows. The window on the left side is the Federated Learning server. The window on the right top is client 1, Federated Learning client 1, and the right bottom is for the client 2. The client 1 is under the same AWS account as the server. This simulates the scenario where you may have distributed data sets within the same organization. And the client 2 is at a different AWS account from the Federated Learning server. This simulates a typical Federated Learning scenario where different Federated Learning clients are from different organizations or companies. And you may see that at client 2, there are a few cross-account rows to assume. So here at the server side, you will see step 0, initialize, step 1, notify, and step 5, aggregate. And at the client 1 and the client 2, they all have same directory architecture. There's a code repo, which is storing the code downloaded from the code repository. There is a local data set, and also models generated, and also client Federated Learning client class. And here we see the configuration files. There's a model.py, which is a global model to train. And here is the configuration file for interaction between the client and the server. And again, client 2 is at a different account from the server. So we have cross-account rows to assume at client 2. While client 1 does not have cross-account row to assume. Now let's start client 1. It is under local data processing. And client 2, it is also under local data processing. And here we're going to start the server. Step 0 is to initialize the resources at the server. And step 1 is to notify the clients that the global model is ready and start local training. And you may notice that client 1 and client 2 both started local training. And at the clients, we can see step 1 is to receive notification. There's a task token. It corresponds to a specific notification from the step function from the server. And step 2 is download the local model. Step 3 is local training. Step 4 is upload local model information and the local model to the server. And now we are at training round 2. You may also notice that we printed out the training accuracy and testing accuracy and the loss after each federated learning training round locally. And they are gradually improving after each federated learning training round. On the server side, you may notice that we have a condition to check. If the condition is satisfied, and then we will end the training. If the condition is not satisfied, it will continue next federated learning training round. The condition we set here is the number of federated learning training round reaches 8. So after 8 federated learning training round, the demo will finish. Now we are at federated learning training round 5.
So Joe, while the training runs are running, question is, how do you efficiently test the global model if you don't have data from each of the individual banks?
The global model, once trained, it will be sent to the individual clients. And the clients are able to test the accuracy based on the client's local data.
Now, Joe, with all the things going on in the marketing world and clean rooms and things of that nature, is that kind of a key area that federated learning can help?
Sorry, could you repeat your question?
So in the marketing world, they've stopped collecting cookies and all that and put in more rules, and you're looking at things called data clean rooms where people can kind of access data, other companies, but it's kind of blocked off. It feels like that could be a really good use case for federated learning. Has anyone talked about that?
I think that is a good use case, but we haven't heard from our clients yet. But we do hear a lot of use cases from finance and from healthcare life science area. Okay. So here actually we tested a global model accuracy. After the training, the global model is actually sent to the local client, and we can test the accuracy of the global model. Okay. So here we show how to build these federated learning operations on AWS. We have a federated learning server on AWS and the federated learning clients on premises and on AWS cloud. On the server side, the AWS step functions iterates federated learning training rounds. For each training round, the step function sends out SNS notifications that are queued by Amazon SQS. Each federated learning client has a corresponding SQS. The federated learning model registry consists of Amazon S3 storing the global and the local models, and the DynamoDB storing the local model information. We also enable DynamoDB Stream to trigger AWS Lambda. Whenever there is a new local model collected, AWS Lambda is triggered to check if there are enough local models collected. If yes, the AWS Lambda aggregates the local models into global models. The resulting global model is written back to the Amazon S3. The AWS step functions then determine if the federated learning training should be terminated based on the constraints configured. for example, if the number of training rounds reaches a threshold. On the client side, the on-prem Federated Learning client uses AWS SDK and CLI to securely access the services at the server. The Federated Learning client on AWS can also use the private link to access the server services securely. There are several advantages for this architecture. First, it uses cloud-native services that have proven security and operational excellence. It's built from ground up for Federated Learning so that you are able to run customized Federated Learning algorithms in these cloud services. Second, there is no direct write from the server to the clients. The clients are able to pull and push information to the server based on their own willingness. The client will be safe and no internal system to be shared by outside entities. Third, the Federated Learning server uses serverless services instead of using a persistently running server, which reduces the computation cost at the server side. Thank you. Are there any further questions?
Awesome. Thank you, Joe. There is one more question, which I think is probably for Na a little bit. And there's asking of how long does it usually take to migrate to SageMaker pipelines? Now, that's kind of a little bit of a loaded question because it depends on how your models are already created, right? If you're already have models that are in Docker containers, then that can be slightly easier. If you're just moving straight Python code, then often you're struggling with libraries and dependencies, and it can depend on how complicated the algorithms are themselves to train and test. Anything you want to add to that, Na?
Yeah, exactly. Depending on what kind of model starting point you have, SageMaker provides many different options for you. You can bring your own container. You can pre-build a container based on the extend a container on SageMaker, or you can refactor your script to bring your own training script. So there are multiple solutions, but usually we start with the discovery stage where it can be like a week to understand the model, and then 2 or 4 weeks, depending on to do the model refactor, depending on how complex it is. And then it took a few 3 or 4 weeks to really using the SageMaker pipeline to define all of the steps that are needed.
Hopefully that answers your questions. We want to thank one of our customers, Authentic ID, who was really instrumental in the design and build out of the MLOps platform. They're a really cool company. They are, as it says, authenticating ID. They work with customers, and they have 28 algorithms that they're putting into production where you can define all the metrics of how you are going to do your biometric identity. So, it's really, really cool, interesting company. If you guys are looking for identity verification solutions or an engine, they're definitely worth checking out. They have a system that we built out that will deploy into your AWS environment, and then you can choose which parts of their algorithms you use to construct your final algorithm. And it comes with a whole MLOps pipeline that we were talking about here to keep those models into production as you're working. So, definitely a really cool company to look at and work with. If anyone has any other questions or looking to do ML modernization, we do assessments. If you go to the AWS Marketplace, you can find the machine learning modernization assessment, or if you contact anybody on the email that you'll get from this presentation, we're happy to sit down, talk with you about your model objectives, how MLOps and SageMaker pipelines could be the perfect fit for you, and help you guys get those models into production. So thank you, everyone, for attending. I don't see any other questions, so thank you for everything.